Hi, we are in the remote studio for a lightning pod with Rohan Kodialam of Sphinx, who's just announced their fundraise with Lightspeed. Special thanks to Bucky for setting this up, but welcome.
Yeah, thanks for having me. Really great to meet you.
Yeah. So, what is Sphinx? What is Copilot? Maybe like what's your history going back into this? We both share a little bit of history from the hedge fund world.
Yeah, no, absolutely. So yeah, my background is in AI research. I was initially at CSL working on transformer-based models prior to GPT, and then transitioned into quant finance. So spent some time as a quant, then actually went back into AI research in finance, where my focus was really building models and agents that could trade the stock market. Super interesting work. I think putting agents into a sufficiently challenging arena really unveils a lot of the hard parts of building AI, where, it can't just look good. It actually has to be objectively correct in order to generate any kind of revenue. And so that's the kind of lessons that we're bringing to Sphinx. And then very broadly, what inspired Sphinx was that so many people were giving us AI tools when I was at Citadel working on AI research and on data science. And those tools are great for the front of office guys writing copy. They were great for the software engineers who are building our platform. But for the people who are working on data, on research, the quants very broadly, we got almost nothing from these tools. And it was kind of a shame, right? It's almost like data is what created AI, and now AI doesn't give back to data in the way that I'd expect. And there are a few critical reasons for that. One is just a simple representation problem. LLMs are good at understanding language, natural or artificial, including, of course, random natural language, but also code, which is just artificial language. And so it's quite a natural decision to say, I'd like to generate code with an LLM or understand code or a code base. On the flip side, traditional data, tabular information, structured data, time series, etc., are not really the native language that an LLM speaks. So you can obviously get those things into tokens, but you'll typically get junk out. So that representation problem was a pretty critical one that we're working on here. And the other is more of a reinforcement problem, which is that a lot of AI workflows, like even, quote unquote agentic workflows, are quite linear in nature, right? There's the loop is usually, I need to do X. Did I do it? If not, try again until it's done. But in the data research exploration phase, there's so much of the EDA, cleaning up data, decisions that are pretty nebulous, pretty hard to validate until you're finished. And then the process of kind of backtracking, checking your work, exploring, even though that exploration may not actually be useful for the goal because you end up taking a different route. That's quite hard. Again, like LLMs are very much mode collapse machines. They want to pick the most likely option and just go down that path. So kind of getting them out of that and having agents that are more exploratory and are more able to ask hard questions like, should I do some kind of EDA, even though there's no point to doing that EDA ostensibly right now, is another component of what we're building at Sphinx. And I think if you combine the two, you're able to get agents that are quite good at helping with real data tasks. They're able to get people to go from just a vague idea of what they want, I want to model this, I want to clean this, to some kind of pipeline that actually enables that in production.
Yeah, awesome. I should specify EDA for those who don't know. It's exploratory data analysis. Any data scientist learns that in a one-on-one class. But if you're a developer and you're encountering it for the first time, that's just it. Like it's the basic hygiene that you need for looking at your data, which is what we call it in like the sort of AI engineering world.
Exactly.
Are you focused on only data scientists? What's your thoughts on like the target market?
Yeah, no. So we really are thinking more about the type of problem than the person. And data scientists obviously only think about this problem. So we are reaching out to them. But a lot of software engineers also do interface with data and often are making decisions around data. In finance, there's a huge community of quant researchers and just analysts more broadly. There are data engineers who are kind of sitting at the intersection of these two spaces. And so we want to help everyone who's working with data. It's really about the question you're asking and not your kind of job title. I see a lot of our existing users kind of interfacing with existing software copilots for software engineering parts of their job, and then using Sphinx for the data science part of their job, where they're still exploring, still figuring out what is the right insight, and then turning to, your Claude codes and other similar tools that once you know what you want, actually doing the software engineering downstream of it.
Awesome. I guess let's just go straight into a demo. We have the
Yeah, no, absolutely.
It's like I like to show not tell, and I think this is definitely a more visual thing. So whenever you're ready.
Perfect. Yeah. Let me throw it up. Can you see my screen?
Yes.
Okay.
Beautiful and big.
Yes. Right. So we are fundamentally interfacing with the Jupyter notebook right now. That's our kind of first port of call. Most data scientists are deeply familiar with it, so we don't want to make them go through a learning curve to use Sphinx. Sphinx is a pretty simple tool. You have your notebook. It works exactly as your notebook works already. You can run cells, do whatever it is you want. And everything that's done in the notebook, of both behind the scenes and visibly, is made into context for Sphinx to think about. Sphinx is a chatbot. Right now in the Copilot, you can talk to it and kind of ask it to take care of any kind of task you want. So I'll give it some pretty basic exploratory tasks that I think act as almost a support vector for what you can do with Sphinx that it's hard to do with, say, Claude Code or with just ChatGPT. So I'll say, okay, load test CSV. And this, of course, now is just code gen. There's nothing like super aggressive about this, but you can see here that even like at this like kind of first step, it's being a little bit careful about what it's doing. It's like not, it seems like this file doesn't exist. Let me actually, temp CSV. Apologies for that. We'll see if it loads it this time. Okay, so now it's hopefully going to succeed, and it's found some data. And this kind of arrives at like the first crux of the problem. It's already going to start doing some EDA for us. But when doing that EDA, you'll see that like we're not able, no, Seaborn, it'll probably do with Matplotlib while it does that. You can see that this is just like raw data that we've pulled up. It's from a Kaggle contest, actually. And one of the challenges of this data is that if you just pass it straight into a model, you're not going to get very good responses. You're just going to get, this is a bunch of numbers. When you're able to actually start doing EDA on the data, you're able to uncover patterns. You're able to see the distributions of what does X look like, what does Y look like, what is the structure of this data? And you can see clearly here there is some structure to this data. It seems to fall into two clusters. So I can ask Sphinx a question along the lines now of like, can you make a model to predict Y from X? Let's see what it thinks up of here. And of course, now it immediately knows that this data is bimodal. And because that relationship exists, it's going to be able to think of models that actually make a little bit more sense than just kind of a random baseline. We typically try to capture the real human data science workflow. So we'll start with a linear regression, which of course we know is interpretability. It's just visualizing the fit. It is obviously bad. Sphinx knows it's bad. And now it's going to say, let me try to fit a slightly more complicated model. Polynomial seems to fit the curve quite well. But even then, is that really the right model? In my opinion, it's fine, but it's not great. I may want to do something a little bit different. I may want to suggest you do a different type of model. And of course, Sphinx can take that from there and say, do some clustering and use that in your model. And of course, now I can give Sphinx some more guidance and it will think about what I've said, make sure it's able to incorporate that feedback and then build something that's a little bit more principled as per whatever my request was. So now it's going to go and let's see. It's going to use k-means, which I think is quite reasonable. Assign cluster labels. And then
this was a big part of my job in like the 2015s. So
like this is a still big part of most quants' job, right? This is what most quants are doing. The cluster model now predicts based on some combination of a one-hot of which cluster you're in. And so like you're able to build these models that are a little bit more customized to the human kind of touch. At the end, I think it actually Sphinx picked a better model than I did when it went for this curve. But realistically, you often find that if you go to your, your cursors or tools like that, and you just say, go here, I have some data and a CSV file trained model, it may just give you this. It may say, in order to be robust, we're going to fit a very complicated model, some like big nonlinear regression or even a neural network. But we find that those things are often overfit, and we want to make sure that we're providing people with something that is really in line with exactly what a human would want to do. A model that's simple, that's based on visual interpretation of the data. And so this is like, I think of a support vector. It's kind of something that you'd find your coding Copilot is bad at doing, but really we are also really a full stack data service. We work on everything from data discovery. So you can tell Sphinx, hey, I have a Snowflake account, go find me this data, and it will go hunt for the data for you. We work on data cleaning. That's really for customers like the bread and butter, honestly. Like a bunch of messy data shows up and they turn it into something that they can immediately do analysis on. Modeling, of course. I think modeling is the flashiest thing. We like to show demos of modeling, but in the end, it's probably the smallest percentage of work that's actually being done by data scientists.
yes.
Downstream of that, visualization, dashboarding, etc. How do you take this model and make it into a plot that you can put in front of your boss and make the point of, here's why our churn is going up. Here's a picture you can look at, and here's all the math that justifies it. So we really cover that full gamut of exploratory work, from raw information sitting in some kind of data lake to an insight on how you can, in the case of a business, make more money ideally. But then in the case of many other domains, we also work with people who are more focused on science, on research, focused on other objectives. And really, we see ourselves as the path from raw data to insight.
Yeah, awesome. So, I mean, there's a lot that you just covered there, and I actually had some questions prepped with Bucky.
Of course.
So we're actually going to go in reverse order because you just brought up the whole dashboarding stuff. How do you tie in on like the um, how does data analysis tie into data pipelines, right? Like like
Mhm.
obviously once I run a Jupyter notebook, then I want it to run on a schedule and so
Yes.
on and
Yeah.
so forth. You and I have both been there. What's the vision, if there's anything?
Yeah, so look, like a lot of people have very set practices around this. Like people use paper mill and things like that. And so I'm not necessarily going to say I love the idea of just scheduling a raw notebook, and but that is the way people operate. And part of the
That's
benefit,
what I do. Wait, what's better than that?
well, at least like I'll say, at least in my past life, we certainly had a process to promote things to prod, and that's something that Sphinx can help with too, right? Like in the end, it just Sphinx has the code, it has why it wrote the code, it has what you did to intervene on the code. It has a huge amount of context that it can then invoke to write things like Streamlit apps, Python scripts, Airflow DAGs, like you name it, Sphinx can help you do it, and then pass that context on to whatever production system people want to be using. We don't own the production system at this time. People schedule it themselves. They use whatever their existing prod system is, but we're able to usually get the code into the format that they need for that. A large part of why getting from your exploratory data science analysis to a data engineering prod pipeline is hard is because a lot of the code written in data science settings is somewhat unprincipled and it's somewhat like a mess at times. Like notebooks lend themselves to that kind of paradigm. So having a Copilot there that can help you, that can understand, why is there this one weird cell that you have to run at the beginning of the pipeline in order to make it work? That gives you an enormous advantage in being able to just allow AI to take care of all that nuance for you.
Awesome. And then sort of recursing back to the steps. Yeah, like so I think people have seen stuff like this. It's a
Of course.
Copilot. It's on the screen. It works with a notebook. Cool. And the other thing that comes to mind is Julius.
Yes.
So how do you see yourself in the broad landscape of like what's already out there?
Yeah, look, like we are very clear that we are building a Copilot for people who are working with data right now. It's a little bit different than I think certain more BI focused plays, which are saying, you don't need to know data science. You just ask a question and then an answer pops out. And like Databricks Genie is kind of like this. Snowflake has a product like this. And so those are useful for a different use case. But what we see in the landscape is that the types of questions that are going to transform businesses are really hard. They're questions like, what can I change about my business to make more money? It's not like how much revenue did I make this quarter? Yeah, like you can probably use whatever Copilot you want for that. But when you ask these harder questions, you do still need kind of a human in the loop, or at least someone to see the artifacts that are being generated. You do want artifacts like notebooks, like code to be generated that are runnable in a proper prod environment, not just in some cloud somewhere. And so we see this as a way to tackle these really hard data problems that traditional code gen or text to SQL or things like that are just not going to be good enough to solve. Those harder problems, we're being ambitious about it, but we also see the kind of returns on those harder problems being massive. Even with some of our initial users so far, some of the more enterprise focused users, they are able to solve problems that span everything from data collection, data cleaning, data analysis, building models, and then eventually being able to like make causal statements, right? Like if we do this to our product, user feedback will go up. And that's the kind of thing that you're not going to get from a Genie or from a Julius or something like that.
Yeah, awesome. And then like, but more generally, like, why is this like subtly different than CodeGen? Like, what do you do to like actually understand data? Does this end with you training your own model for understanding data, or like, how does this work?
Yeah, I mean, I think we're cautious about just like blanket saying we're going to train our own model to do everything. There is a lot of natural language processing, both in terms of like we are writing code and there are human inputs coming into our system. And so we don't want to discredit that. And we also want to be benefiting as OpenAI and Anthropic make advances in that space. On the flip side, yeah, these models are bad at understanding data. And I think the way to kind of contextualize that is almost humans have invented so many tools to understand data, right? Like with everything from Excel to Matplotlib to Seaborn to Altair. These are all just ways that a human can turn piles of information into some tokens effectively that you and I can consume through our eyes and ears and make sense of the data. And we need to build the same layer for AI. So that's really like what we see as one of the two main differentiators of what Sphinx is doing. Right. Like if you're building a software Copilot, you don't need that. We absolutely need that. So we need to be able to say for an arbitrary piece of data, how does that data get turned into tokens? And sometimes it's easy, like in the example I showed you, which is relatively straightforward. It was two-dimensional data. So you make it a scatter plot. You look at the scatter plot and you're like, oh, it's bimodal. I can then model in a certain way. If I gave you a gigantic table, a terabyte size table that sits in Snowflake, I certainly hope that Sphinx would not make a scatter plot. And we won't. We'd instead think about, okay, like, are there aggregations we can do? Is there metadata we can do? If it's high dimensional data, how do we reduce that dimensionality? And then it might even have to become iterative, where you do, say, a t-SNE and you look and you say, okay, there's not really any clusters here. Like, can we do it a different way? Or there are clusters. What do each of those clusters mean? So the question of how do you turn data into tokens is a pretty hard one, and one that just I don't think comes up in software. Um, that's one. And then the other is, of course, what does the agent do? And the agent here is a lot more vague in the types of tasks it's given. It's given a task like, why are my customers churning? That's a pretty common one. And so when someone asks that question, it's not like the answer is just, okay, they want a churn model. I'm going to set up a logistic regression and I'm done. It has to be EDA, building the pipeline, running some kind of model, of course, looking at that model, validating the model, maybe looping back. And so that, again, is behavior that you don't necessarily want in a software copilot. In fact, I'd feel like if I were to use, say, Cursor and it were to do that, I'd get kind of annoyed, right? It's like, why do you keep backtracking? Just kind of do the thing and move on. And often the spec I'd have is a lot more like intelligent. I'd say, like, I want this feature implemented this way. But on the flip side, with data science, I absolutely don't want that. I want it to be really exploratory. I want it to kind of question itself and solve problems in a very different way than software.
Yeah. Yeah. And then on just I've dived into the data engine world for a bit. Your thoughts on like semantic layer type things, and then, I think for the agent builders, the equivalent is like some kind of pre-cached workflows or definitions, right?
So we do that. So look, one of the things that's hard about data,
you can show it if you have something.
Well, so that's all under the hood. And in fact, like, there's a reason we do it under the hood, and part of it is that, unlike code, where typically a code base is self-documenting, you read it, you know what it does. But data, there's a lot of skeletons in the closet, so to speak, where you need your senior data scientist to be like, I'll actually like do the join on this column because this column's broken or something like that. We collect that knowledge, that kind of tribal knowledge, and turn it into something a little bit more institutionalized. But what we see as important here is that the more structure you put on that problem, typically, A, the harder it is for it to actually be accurate, and B, the harder it is for users to onboard onto it. So I think the classic example of this is Palantir, right? Which is obviously an amazing thing when it works, but the amount of effort to kind of get everything into a super formal ontology is quite high. So we are quite.
You're talking about you were a customer of the Palantir finance product.
So we actually weren't at Citadel,
okay.
But
I see.
We were quite familiar with the product, and so like the idea of like you have to onboard over several months, you need like a forward deployed engineer to come and help you. It makes sense if you're willing to make that commitment upfront, and then also promise to yourself that you'll maintain these ontologies.
In 2015, I interviewed for that exact role. For I think it was called Metropolis at the time.
Oh, interesting.
Yeah.
Okay.
Anyway,
yeah, and so that's hard, right? And when it works beautifully, and when it doesn't, it kind of just like isn't useful. So we want to build softer ontologies, and so we do it under the hood. We do it through effectively like an embedding layer, where we're able to say every time that Sphinx is stopped and the user takes the wheel and does something different, anytime they do something a little bit weird, anytime Sphinx has to kind of explore a little bit more than it was expecting to learn how to find something or how to do something, those are all collected, embedded, and then retrieved as needed. We see that as a pretty core part of closing the gap between, just what you can understand from raw data and what you need to actually do data science. Again, it varies a lot by company. Some people have great ontologies and then Sphinx can tap into them, and cool, it works. Some people have really good documentation on their data. Other people don't. And if they don't, we can absolutely help them bridge that gap. In the end, your human data scientists are able to do a good job because they have a lot of state in their head, and we want to get as much of that state out of their head into our system as possible so that we can automate more.
Yeah, I would push back mildly, just as a consumer of these things, on like keeping it all sort of black box with you guys, because obviously I want to look at it.
We absolutely, for our users, we expose it, so users can have access to it. It's just that we don't have we don't expose like a standard ontology, right? In the sense of like there's like a parallel database for maintaining somewhere. It's really just maintained as like an insight store, and of course it's separated by person and pretty strong protections on that. And then each user is able to kind of interact with only their own effectively like set of memories and insights.
So let's just talk about like customer learnings. Like obviously you're coming out of like kind of quote unquote self today.
Yeah.
So what do you expect when you started Sphinx, and what have you learned since that sort of you had to change your mind on?
Yeah, like whenever anyone like starts thinking about data, you always go to like the cool use cases first, right? Like the Kaggle style use cases of like, oh, I'm going to build like the new AutoML that takes hard problems and solves them really well.
It's the
In the
dream
end,
that has killed 1,000 startups. Yeah.
yes, I'm happy that we don't think that way. We're very early and we don't think that way. I don't think anyone cares. People care a lot about data cleaning, data provenance, making sure that the pipelines make sense, visualization. And so these problems are now our bread and butter. Modeling is still part of it, but it's not the biggest part of it. That's obviously one key learning. The other is just data scientists are very opinionated people. And I was a quant, I was a data scientist. And really a large degree of what we need to do is make tasteful decisions. It's not just enough to say like, we'll just do whatever you want in the data science world, which I think to be clear for coding is kind of what you can do, right? You can just say like, you tell me what to do, I'll do what you want. A lot of our initial user testing is actually kind of funny. They'll ask us things to do something bad. They'll say like, oh, this data is nonlinear. Can you train a linear regression? And what they're looking for is not obedience, but they're actually looking for Sphinx to push back and say, oh, like, that's a bad idea. I don't think I should do that. And so we have to make sure that we're not just building a Copilot that obeys and follows instructions, but rather is a genuine thought partner. And data scientists expect that. If it's not, then they'll say this is like, it's like working with an idiot. I don't want to work with this anymore. And so we need to be able to deliver on that level of quality. That's become pretty big for us, making sure that we deliver something that we're proud to use and we're proud to sell to our customers, and that would meet our own standards when we were data scientists.
Yeah, awesome. Let's talk about benchmarks. Well, on your landing page, you have Dabstep Hard. Never heard of it. It sounds like it's a cool electronic mix. Tell me more. What's this? And is this the standard?
Yeah, no, okay. So like, first of all, the question is there a standard? The answer is no. Right? I'm not going to pretend.
Yeah.
I think in all AI use cases, like benchmarks are one of the hardest things to get right. Dabstep is a problem set made up by Adjun and Hugging Face. It tests reasonably complicated questions, especially the hard ones, multimodal, no, not multimodal, but like multi-data set questions coming from fintech. And so when we think about the questions that Dabstep has, they involve data discovery, data cleaning, building a model, coming to a conclusion, understanding semi-structured metadata. So there's quite a few things that go into this mix. We like Dabstep for a couple of reasons. One is that it's very much grounded in like real world use cases, like exactly what they say on their website. Two, it's been used by others. So like, for example, Google Gemini has a data science copilot, which they've benchmarked. People have benchmarked the standard thinking models, O3, latest Claude model, etc. And so, yeah, that's the one.
I like showing,
Yeah, no, of course. Yeah,
people,
this is like, this is exactly how we discovered this data set too, like Googling around. And so we like that kind of, it's real world data that others are benchmarking on so we can get good comparisons. And we're doing quite well on it. I mean, we've progressed actually beyond this, but we're not like super interested at this time in like publishing results or like benchmark chasing or writing papers. So we're more focused on making the product really good for our users. But we do want to have some confidence that what we're doing is world-class and can actually deliver a good experience. Now, taking a step back, what do I not like about Dabstep, and why do I not care about it all that much? I mean, I'll give you an example of one of the questions we get wrong on Dabstep. There's one of the first questions, it's not even in hard, so it doesn't even figure in our stats. It's like, which country is the most fraudulent? So I give this question to Sphinx. I'm like, oh, I'll obviously get it right. Has some data on fraud by country. It does a group by, it says, okay, Netherlands. Okay, I'm like, cool. Okay. And it's wrong. And I'm like, well, why is it wrong? I go manually do it. I come to the same conclusion. And then I finally realized that what they meant was what country has the highest percent of fraudulent transactions, not the highest number. And that's Belgium in their data set. And so like this to me is like the quintessential problem. If you build a good Copilot, then the user sees it and they see the code and they see the logic. This is a 0-second fix. You say, actually, I meant the percent, and it fixes it and Sphinx is right and everyone's happy. But if you're in this fully autonomous mode, you're not getting credit for that. So we want to find problems where the hard part is data exploration, data cleaning, and not just like kind of bad questions, right? Like resolving the ambiguity on questions is something that we absolutely want a human to do. Like even if we did have 99.9% confidence on resolving that ambiguity when it comes to someone's business, we don't want to just like leap to a conclusion that could be erroneous. We'd rather have the human kind of give input there. So that's one big problem with it. And the other is that like the scale of the problems is not big enough, in my opinion. So we're working with enterprises which have thousands of tables sitting in Snowflake and they want to work across all of them. And so the benchmark may just not be objectively hard enough. It may be hard for the wrong reasons. It may be hard due to ambiguity rather than size of data, complexity of data, the messiness of the data, which is, obviously hard to do in a simple benchmark.
Yeah, I think like the challenge is like, I mean, coding agent companies have the same issue with Swebench, right? It's the
Exactly.
standard, but like no one likes it. And
Hmm.
other people play the Swebench game, and then if you don't, you kind of fall behind. Like, how do you communicate how you're good? And then
That's right.
the
And
answer is
that's exactly why we did it. Yeah, because this is a good way to communicate. It's easy. It's a number. It's a graph. But yeah.
like at some point, like, okay, so you're gonna do this for now, and like it's fine, you're state of the art. But at some point, like you have to kind of move on, and like I don't know what's next after this of like convincing your customers or potential customers of like, no, like we actually objectively measure with other companies. Like I'm trying to figure out like what's after this kind of benchmark, and I don't have an answer.
Building our own, really. I mean, look, like one of the things that is good for startups but bad for, I guess, like data scientists as a whole is that there's very poor benchmarking for data science. There's very little data for data science, even for coding, right? Like at least you could go onto GitHub and like go scrape a bunch of code that's usually like pretty good to train on. But for us, I mean, you don't get that, right? All the data science traces, the like kind of traces of logic that lead from idea to insight, there's some notebooks that are committed up. I don't even know, like you're sometimes not supposed to commit notebooks. I mean, and committing them publicly on GitHub, and they're full of junk, and I don't have the kernel state, and I don't really know what data you imported, and it's probably all broken. I mean, it's very hard to contemplate how you'd use that to go and, either improve models or evaluate models. So there is a data problem here, right? It just, there's no data for data science. And that's part of what we are going to be able to solve as our team builds expertise in the space. We'll be able to come up with benchmarks that are quite robust, and that'll both serve to prove to people that, yeah, our models are improving constantly and are going to tackle these harder problems that are reflective of what real enterprises are dealing with, but also give us the ability to kind of iterate on our research cycle. So our priority one from a research standpoint, well, our priority zero was making sure that our models were good enough to actually deliver and, win on things like Dabstep. Priority one is building benchmarks, right? We need to set up the feedback loop. And so that's currently one of the things that we're working on.
Awesome. Cool. Well, I guess we'll just wait for those kinds of updates. But otherwise, how should people check you out? Are you looking for any specific ICP that like, if you're this, you're frustrated with this, you should try us out.
Yeah, look, like basically anyone who uses a Jupyter notebook, as far as we can tell, is a little bit frustrated at the fact that everyone else has Cursor and they have copy pasting things out of ChatGPT. So that's like kind of the core emotional frustration that I felt and that we want to solve. In terms of ICP, look, we work with every industry. We're able to offer pretty strong data guarantees around zero data retention, making sure the compute stays on your side. So we work with everyone from finance, consumer retail, consumer packaged goods, other tech companies, of course. And our product is available now as of today. We launched publicly today, Sphinx.ai. We have a very, very generous free tier thanks to Lightspeed. So we're able to kind of support quite a bit of use. And really, like the way we see the product working is that you are in a notebook, you download Sphinx, your notebook experience gets 10 times better, right? We have existing users who have legitimately been sped up more than 10 times in terms of the amount of like time they're spending actually writing code rather than thinking about insights.
Yeah. 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 Awesome. Okay, cool. Congrats on your launch and thanks for spending the time.
Yeah, really appreciate it. Thanks so much.